Hello, my name is Mayra Arangure. I am a student at Cal Poly Pomona here once again to go over an Aero 3271 problem. And today we will have to figure out how many cycles the streamer can withstand before experiencing uncontrollable crack growth using the iterative method. This method can be accurate if you use multiple cycles, or somewhat inaccurate or very inaccurate with the less cycles you iterate with. So for the sake of going quick, let's just go over it. So we have a 2024 T3 aluminum sheet that experiences a stress that oscillates between 45 ksi and negative 25 ksi. Through inspection, we detect a crack that is 0.005 inches. And we have to estimate the number of cycles the stringer can withstand before experiencing uncontrollable crack growth. And this crack is a solo edge crack. So a few equations that you should know is the stress intensity modification factor, beta, right here. This is the intensity factor for a solo edge crack in tension. There are multiple modifications factors. You just have to be able to determine which type of crack you have so you can use the proper modification factor. You also have to know the stress intensity factor, which is given right here. The change in intensity factor, which would just be the same equation as above, which is the change of stress. The margin of safety against fast fracture. The equation change in crack growth, which you can find in table 4.31 for your C and M. Your equation for your AI plus 1. And then right here is your BI and your KI plus 1, which changes. So let's take a look at a quick example if you're trying to figure it out with just one cycle. Each of these is just a different guess. And when you're doing it with one guess, you kind of want to make sure that you go with a huge number of cycles. So for example, with my first guess, I said, let's go 100,000 cycles. And we kind of see that with 100,000 cycles, my KI plus 1 is 23.19. And ideally, when you're guessing, you want your KIC to converge to your KI plus 1, or vice versa. Your KI plus 1, you want it to converge to your KIC. So since in my first guess I was above, I said, okay, let's go smaller, 95,000. And we're now below 23. So I was like, okay, let's bump that to 98,000. And I see it's getting closer until I finally got to like my final guess, and I made it to 98,210. This obviously takes a lot of guesses if you're only doing it with one cycle, and fair warning, if you're doing it with one cycle, you will get very inaccurate number. Like your margin of error will probably be like somewhere in the hundreds place. So if you're going to use iterative method, you want to use multiple iterations. So let's take a look when we try something a little bit bigger, like 7 cycles. So you notice right here in our first cycle, we start out with 0.005, right? Because that's the length of a crack that we were able to detect. You plug in that and all your known values to your beta, your KI, your MS, your change in KI. And once we get to here, the number of cycles, since I'm now guessing with more cycles, you want to go with the lower number. So this time I chose 5,000, but this number can be any number that you choose. It can be 4,000, it can be 7,000, right? But because I wanted to fit it in 7 cycles, I decided to go with 5,000. And then with that, you plug in your change of A, your AI plus 1, your beta I plus 1, your KI plus 1, and you look at your margin of safety. As you can see, our KI plus 1, we're at 8, and we need to reach to 23. So we keep going. Now, this is where some people might see a mistake. You want to make sure that your AI, this one, comes from this one right here. So your AI plus 1, you want to make sure you plug that into your new AI in your second iteration. Like some may do the mistake of your second iteration being 1 plus 0.005. That's incorrect, and you're not going to get the correct like conversion, you can say. So just keep an eye out for that and make sure that your AI goes back to this in your second iteration for your new AI. You do the same thing. You go through it all over again. Right here, your second AI plus 1 will now become your AI in your third iteration. You kind of just keep going all the way down. And then for your number of cycles, I kept it consistent because it's easier to calculate. And I knew where to stop because once I reached this point right here, when I had 5,000 cycles, my margin of safety became a negative number. And I was around, for my KI plus 1, I was around like 23.3 around there. I don't remember exactly. So I was like, oh, 5,000 is too big for my sixth iteration. So let me go smaller. And that's where I decided, okay, instead of 5,000, let's do 3,000, which is a smaller number of cycles. And then it looks like I pass my margin of safety and I'm at 22.06, which I'm like, okay, now let's do our last iteration because we want it in 7 cycles. And I decided, let's try 1,000 first. And I realized, oh, my margin of safety is negative. I can't do that. So then I said, okay, let's try 9,000. It was still negative, but it was definitely getting closer to a positive number. So I said, okay, let's do 800. And then that gave me a positive margin of safety. My KI was getting pretty close as well. And I said, okay, let's keep trying the number. So like I did 825, 850, 870, until I finally made it to 875. And if you look, my margin of safety is 0.0053, which ideally for multiple iterations, you want your margin of safety to equal to 0. And again, you want your KI plus 1 to converge to KIC, which is the max KI that your cycle can withstand, right? And so I was satisfied with these values. I was like, okay, this is where we can stop. So once you finish your iterations, to get your total number of cycles, you are essentially going to sum. Here, let me erase some of this mess real quick. Okay. Once you're done iterating, you want to sum all of these to get the amount of cycles that the part can withstand before fast fracture. I just put this down right here below. So the number of cycles before fast fracture is going to equal the sum of the cycles from your iteration. So we just did 5,000 plus 5,000 plus 5,000 plus 5,000 plus 5,000 plus 3,000 plus 875, which gives us a total of 28,875 cycles. And that's basically it. Hopefully this helps you understand a little bit better how to do the iterative method. It is very tedious, and I highly recommend doing it on either MATLAB or on Excel if you want to, like, every time you plug in a number to see it change, that type deal. But yeah, it is a very time-consuming method, and if you want to get a very accurate number of cycles, it's best to do the calculus method. But if you don't want to do the calculus method, you have the iterative method. It's just a little bit more time consuming, and you have to have more iterations to get to a more accurate number, you can say. But yeah, I hope this helps, and feel free to reach out to your professor if you have more questions. Thank you.